As applications grow in size and complexity, managing all the code in a single file becomes impractical and hard to maintain. To address this issue, it's beneficial to split the code into multiple smaller files, each encapsulating a specific functionality or feature. These smaller files are called modules. Let's go over the benefits of modularity. The first benefit is maintainability. Smaller, modular files are easier to understand, debug, and test. The second benefit is code reuse. Modules can be reused across different parts of an application or even in different projects, reducing code duplication. The third benefit is abstraction. Modules allow developers to hide implementation details while exposing a clear interface, making it easier to interact with the code. Practical implementation. Imagine you have a programmer class and its related functionalities divided across multiple modules for better organization. You would place the programmer base class in its own file and, for example, the front-end programmer class in a separate file. As these classes grow and gain more methods and enhanced functionality, managing them becomes easier since each class is in its own file, or in other words, its own module. Module systems in JavaScript. Historically, JavaScript did not support modules natively, and various solutions were developed. One of them being AMD, which stands for Asynchronous Module Definition. This was primarily used in browsers, and this format allows modules to be loaded asynchronously. Another module system is CommonJS. This is used in Node.js, and this format is designed for server-side development. Another module system is UMD, which stands for Universal Module Definition. This combines the approaches of AMD and CommonJS, making modules usable in both the browser and Node.js environments. ES6 Modules. With the introduction of ES6, JavaScript now natively supports modules in the browser. This system uses import and export statements to handle dependencies. This course will cover CommonJS for server-side applications and ES6 modules for browser-based JavaScript, providing you with the skills to work flexibly with JavaScript in multiple environments. In conclusion, understanding and using modules in JavaScript not only improves the structure and maintainability of your code, but also enhances its scalability and reusability. By adopting modern JavaScript module standards like ES6 modules and CommonJS, you ensure that your applications are robust, maintainable, and ready for growth. What are the key benefits of using modularity in JavaScript applications, and how do modules improve maintainability, reuse, and abstraction? The key benefits of using modularity in JavaScript applications include maintainability. This leads to smaller, modular files that are easier to understand, debug, and test. The second benefit is code reuse. Modules can be reused across different parts of an application or in different projects, reducing code duplication. The third benefit is abstraction. Modules allow developers to hide implementation details while exposing a clear interface, making it easier to interact with the code. By organizing code into modules, you make the application more manageable, enhance its scalability, and improve overall code quality. How do CommonJS and ES6 modules differ, and why is it important to understand both for developing JavaScript applications in various environments? CommonJS and ES6 modules differ primarily in their usage and syntax. With CommonJS, it is used in Node.js for server-side development, and it uses the require function to import modules and module.export to export them. With ES6 modules, this is supported natively in browsers, and it uses import and export statements to manage dependencies. Understanding both is important because it allows you to work flexibly across different JavaScript environments, using CommonJS for server-side applications and ES6 modules for browser-based applications, ensuring compatibility and leveraging the strengths of each module system. Modularity is a fundamental concept in software architecture that helps organize code in a way that enhances maintainability, reusability, and scalability. Let's apply these principles using the programmer class in a Node.js environment. So let's consider the principle of cohesion. Cohesion refers to how closely related and focused the responsibilities of a single module are. High cohesion within modules often leads to better code maintainability and understanding. In the context of Node.js, you can create a module for the programmer class, so each module in Node.js has its own scope, and anything defined in the module is private unless it is explicitly exported. So let's create a new folder, and I'll name this _ Node.js. Now within it, I'll create a new file, and I'll name this programmer.js. So within it, I can define the programmer class. So I'll say class programmer, define my constructor function. So it takes in a name and the preferred language of the programmer. So I'll say this.name and this.language. Now implement a simple method for code, which is just console log. I'll say this.name is programming in this.language. End that with a period. So now this class is only accessible within this file, so within this module. So we want to export it. So I'll write a comment, export the programmer class as the module's default export. So in order to make this class available in other files, I can say module.exports, and I will assign it to the programmer class. So by doing this, this makes this class the default export. Now I could also put it inside a JavaScript object, and by doing this, it now becomes a named export rather than a default export. So I'll undo that with Command Z. So now using the programmer module, in another file, I'll create index.js, and I want to utilize the programmer class in this file. So I need to import that. So I can do const programmer, and I will use the built-in require function and pass in a relative path to where the programmer class is, or the programmer module is. So it will be ./, meaning the current directory, and the name of the file, which will be program. I can end that with a semicolon. So now I can create an instance of a programmer. So I can say const, I'll say Steven equals new programmer, passing in my name and the preferred language of JavaScript, and I can call Steven.code. So the importation here utilizes the require function provided by CommonJS in Node.js. So Node.js refers to server-side environments. So let's bring up the integrated terminal, and I'll navigate to Node.js, and I will run the index file, so node index.js. And here we see outputs what we expected as the console statement. So I log here, the console statement defined in the code method. So this was achieved through a default export. Now if I were to use a named export, right, so I put it inside a JavaScript object and save that. Now in order to utilize this, I would need to destructure it. Put it within curly braces. Now if I bring up the integrated terminal, up arrow and run it again, we get the expected result. But in this case, since we are just exporting one class, it makes more sense to make it a default export. Clean this up with Command Z. So encapsulation and privacy. By structuring your application into modules and only exporting what is necessary, you enhance encapsulation. For example, if there were private methods or properties within the programmer class, these would not be accessible to consumers of the programmer module, who only receive what is explicitly exported. So the encapsulation ensures that only the intended public interface of the programmer class is exposed and used. In conclusion, this lesson highlights the importance of modularity in software development, particularly in Node.js using CommonJS Modules. By organizing code into cohesive modules and properly managing exports, developers can create maintainable, reusable, and scalable applications. The modular approach not only supports good software design principles, but also ensures that each part of the application can evolve independently. Why is high cohesion important in software modules, and how does it contribute to the maintainability and understandability of the code? High cohesion in software modules means that the functions and responsibilities within a module are closely related and focus on a specific task. This is important for two main reasons. The first being maintainability. Modules with high cohesion are easier to update and debug since changes are localized to a specific area with related functionality. This reduces the risk of introducing errors elsewhere in the system. The second reason is understandability. High cohesion makes the code more intuitive and easier to understand. When a module has a single, well-defined purpose, developers can quickly grasp what it does and how it works without needing to sift through unrelated code. In summary, high cohesion leads to more organized, manageable, and comprehensible code, making the development process smoother and more efficient. Explain the concept of encapsulation in the context of modular programming. How does using modules and Node.js enhance encapsulation, and what are the benefits of this approach? Encapsulation in modular programming refers to the practice of keeping a module's internal details private and only exposing a limited, necessary interface to other parts of the application. In Node.js, using modules enhances encapsulation by scope isolation. Each module has its own scope, meaning its variables and functions are not accessible outside unless explicitly exported. By only exporting necessary parts of a module, you control what other parts of the application can interact with, reducing the risk of unintended interference and misuse. Now, there are three main benefits. The first is improved security. Sensitive or complex logic is hidden, preventing unauthorized access and potential misuse. The second benefit is the ease of maintenance. Encapsulated modules can be updated or refactored independently without affecting other parts of the application. And the third benefit is clear interfaces. Well-defined interfaces make the system easier to understand and use, promoting better code organization and collaboration. In summary, encapsulation via modules and Node.js leads to safer, more maintainable, and better organized code. What is the syntax for exporting a class or function as the default export in a CommonJS module? And how do you import and use this default export in another file? In CommonJS, to export a class or function as the default export, you use module.exports. To import and use this default export in another file, you use the require function. So for your exercise, create a file named groceryitem.js and implement a groceryitem class with the properties of name and quantity. Then implement a display method. Export that file or module and utilize it in index.js. So for your exercise, here in the Node.js directory, I'll create a file and I'll name it groceryitem.js. So within it, I'll implement this class. So it's class groceryitem, then our constructor. So it'll take in a name and a quantity. So I'll assign these properties for the name and for the quantity. And then we'll have a display method. So log and then tab, backtick. So I'll say the interpolation of this.name times this.quantity. So I implemented this simple class, and now I want to export it so that I can import this class and utilize it elsewhere. So module.exports, and I'll make it a default export. Assign this to the groceryitem class. And so this enables me to import and utilize this class in other files. So in the same directory, I will create a file index.js, and I will use the CommonJS syntax to import it. So I'll say const, and the name of that export is groceryitem, assigned to, and I use the built-in require function in CommonJS, and the directory is groceryitem. So now I can utilize this class, groceryitem, as if it was defined in this file. So I can say const item new groceryitem. So the first parameter it accepts is name. So I'll say apple. So apples as the argument. And for the quantity, I'll say 4. So now I want to call item.display. Let's bring up the integrated terminal. So I'll do Command J. It'll be Control J on Windows. And I will navigate to this file. So I'll run node index.js. And here I get the expected output. So let's cover modularizing the programmer class using ES6 modules. In the previous lesson, we used CommonJS Modules in order to import and export modules in server-side environments using Node.js. So with ES6 modules, this provides a modern and cleaner syntax in order to achieve the same thing for JavaScript files that run in web browsers. So consider this scenario. We want to ensure that certain properties of our programmer class, such as skills, are kept private and managed through a weak map. We'll separate the concerns into two modules, one for the weak map and the other for the programmer class itself. So here in our directory _practice, I'll create a new file and I'll name this programmerskills.js. So this module will maintain a weak map to store private data related to programmers. So let's create that weak map structure. So programmer skills is assigned to a new weak map. So now we'll create a function. So I'll name this setSkills. This will accept two parameters, so a programmer object and the skills. And we will just update the weak map. So it'll be programmer skills.set. So the first parameter that we need to pass is the key. So that would be the programmer object or instance. And then the value. So that would be the skills. So now we'll create another function for retrieving the value. So we'll name this getSkills. This accepts one parameter, which will be the programmer. And we'll use that as the key in order to return the value. So programmerskills.get, and then programmer as the argument. So these functions are only available within this file. So if we were to use CommonJS syntax in order to export these two functions, so we can use it elsewhere in our program, we would need to do module.exports, then a JavaScript object, and specify setSkills and getSkills. But with ES6 modules, we have a cleaner syntax to accomplish the same thing. So we can remove this and just use the export statement. So now both these functions are available to be used in other files. So let's create another file in our _practice directory. And I'll name this programmer.js. So this module defines the programmer class and imports the functionality from programmer skills to manage skills privately. So we'll use ES6 module syntax to import those two functions. So I'll use the keyword of import, and then curly braces, setSkills, and getSkills. Now we use curly braces because we are destructuring it. So we use the from keyword, and then we'll specify the path to the file. So it's // for the current directory, and then programmerskills.js. So now we can utilize these two functions in our class. So it'll be class programmer. We'll define our constructor function. This accepts two parameters, so the name and the skills. So now let's assign the name property. And let's utilize that function in order to set the skills and manage it privately. So the first argument will be the this keyword, meaning this current programmer object, and the value will be the skills. So let's define another method. I'll name this code. So this will log, so tab, and then backticks. This.name is coding in. Then we'll utilize the getSkills function that we imported and pass in the this keyword, so this current programmer object. So once again, we will use the export keyword, which is provided in ES6 modules, and we'll utilize this in our index.js file. So once again, we use our import statement, import the programmer from programmer.js. So let's create an instance of this object. I'll say dev, new programmer, the name of Steven, and the skills of JavaScript. So now we will call the code method. So now in order to utilize ES6 modules and have it executed in our web browser, we need to update this script tag. So instead of the type being text/JavaScript, we'll update this to be module. So it's treated as an ES6 module. So let's start live server. So we'll bring up the command palette with Command Shift and P. Then it's live server, open with live server. And then we can inspect. Let's go to our console. And let's resize this. So here we see our expected output when we call the code method, which is Steven is coding in JavaScript. So another thing I want to show, here in our programmer.js file, we exported our programmer class, but we could also make this a default export. So rather than using the export statement here, I'll remove that, and I can say export default programmer. So now when we go to our index.js file, because it is a default export, I can remove the curly braces and save it. Let's see our output. And here we see, actually let's clear it again just so it'll make it more easily viewable. I can save it again, and I get our expected output. So this shows how we can use ES6 modules in order to organize our code. So as our applications grow in size, we want to split up our functionality into different files. So let's cover some key points. The first is modularity and privacy. By separating the programmer class and its skills management into different modules, we keep implementation details hidden and only expose what is necessary through exports. ES6 modules. Using import and export statements, we can clearly define dependencies and how modules interact. This approach is cleaner and more maintainable than older module systems. Webpack and browser modules. While modern browsers understand ES6 modules natively, complex applications might benefit from tools like Webpack for bundling modules, managing dependencies, and optimizing load times. In conclusion, this setup illustrates how to effectively use JavaScript modules to encapsulate logic, manage privacy, and expose a clean public API. This modular approach not only aids in code organization, but also enhances security and scalability in web development projects. How do ES6 modules enhance code maintainability and organization compared to older module systems? ES6 modules improve maintainability by providing a clear structure for defining and managing dependencies with import and export statements. This helps keep the code organized and easier to manage. What are the benefits of using tools like Webpack in conjunction with ES6 modules for modern web development? Using tools like Webpack with ES6 modules helps bundle and optimize code, managing dependencies more efficiently. This improves load times and ensures that all necessary modules are correctly included, making the development process smoother and the application faster. So for your exercise, use the ES6 module syntax and create a file named groceryitem.js and implement a grocery item class with the properties of name and quantity, then implement a display method. Export that file and utilize it in index.js. So you implemented this exercise previously and you use the CommonJS module syntax in a Node.js environment. But in this case, we will implement these files and utilize it in a web browser. So to implement this, in the directory _practice is where I have my index.html file. So I'll create a new file, groceryitem.js. So I didn't implement this in the previous lesson. So to help us save time, I'll just copy this. And I will paste it in here. But currently I'm using the CommonJS syntax. But instead, I want to use the ES6 module syntax. So I'll make the grocery item class a default export. So I can do that with export default and then grocery item. So now I can import this in my index.js file. So I'll use the keyword import and then grocery item from groceryitem.js. So now let's create a new item equals new grocery item of bananas and a quantity of 5. Then I will call item.display and I will save it. Let's resize this so we can see the web browser. Close the sidebar with Command B. And here I see the expected output of bananas times 5. In the landscape of modern JavaScript development, especially when building browser applications, the roles of transpilers and bundlers are crucial. These tools help manage and adapt code for various environments, ensuring compatibility and efficiency. Transpilers. A transpiler is a type of tool that transforms source code written in one programming language or version, like modern JavaScript ES6, into another version that may be more compatible with current environments, such as older JavaScript ES5 that all browsers can understand. A popular transpiler is Babel. One of the most widely used transpilers, it allows developers to write modern JavaScript while ensuring that the code runs smoothly in environments that only support older standards. For instance, features like classes, the let keyword, the const keyword, arrow functions, and template literals introduced in ES6 are not universally supported in older browsers. So suppose you have a programmer class defined with modern JavaScript features. Using Babel, this can be transpiled to be compatible with environments that do not support the latest JavaScript syntax. Now let's consider bundlers. A bundler aggregates all the modules in your project, and sometimes their dependencies, into a single file or a few files. This process is crucial for optimizing load times and managing resources efficiently. A popular bundler is Webpack. Webpack is the most popular bundler in the modern web development toolkit. Webpack not only bundles files, but also minifies code and provides optimization, like tree shaking, which refers to removing unused code. So an example with Webpack, you can configure Webpack to bundle your JavaScript modules, including the programmer class module, into a single file. This bundled file is then included in your web application, ensuring that all script dependencies are resolved and managed efficiently. So why would you use these tools? Well, one reason is compatibility. It ensures that modern code works in environments that are not up to date with the latest ECMAScript standards. The second reason is performance. It reduces the size of the code and the number of server requests required to load your application. And third is for development efficiency. It simplifies development by allowing you to use modern JavaScript features without worrying about browser compatibility. While these tools are essential for browser applications due to their varied support for JavaScript standards across browsers, Node.js environments generally do not require such tools for running JavaScript code, as Node.js is typically up to date with the latest JavaScript features. However, bundlers like Webpack might still be used in Node.js applications for optimizing the application deployment. In conclusion, understanding and utilizing transpilers like Babel and bundlers like Webpack is essential for any modern web developer looking to create efficient, maintainable, and compatible web applications. They are especially important when the application needs to be scaled or maintained across different browser environments. What is the primary function of a transpiler in modern JavaScript development, and why is it important? The primary function of a transpiler in modern JavaScript development is to convert code written in newer versions of JavaScript, like ES6+, into older versions, like ES5, that is compatible with a wider range of environments, including older browsers. This is important because it ensures that modern JavaScript features can be used by developers without worrying about compatibility issues, allowing the code to run smoothly across all browsers. How does Babel help in making modern JavaScript features compatible with older browsers? Babel helps make modern JavaScript features compatible with older browsers by converting newer JavaScript syntax and features like classes, the let keyword, the const keyword, and arrow functions into older syntax that all browsers can understand. This process, called transpiling, ensures that code written with the latest JavaScript standards can run on any browser regardless of its version. What role does a bundler like Webpack play in optimizing web application performance and resource management? A bundler like Webpack optimizes web application performance and resource management by combining all your JavaScript modules and their dependencies into a single file or a few files. It also minifies the code and removes unused parts, by utilizing tree shaking, which reduces the file size and the number of server requests needed to load the application. This leads to faster load times and more efficient resource usage. Why might Node.js applications generally not require transpilers like Babel, but still benefit from using bundlers like Webpack? Node.js applications generally do not require transpilers like Babel because Node.js often supports the latest JavaScript features. However, they can still benefit from using bundlers like Webpack to optimize performance by combining multiple files into one, reducing file size through minification, and managing dependencies more efficiently. This makes the application faster and easier to deploy. So let's set up our JavaScript development environment. So first we will cover installing essential tools with npm. Before you start, ensure that Node.js is installed on your machine, as it comes with npm, which stands for Node Package Manager. This tool is crucial for managing third-party libraries and development tools. With npm, we can install open source packages to utilize in our projects. So let's open up the integrated terminal. I can do that with Command-J or Control-J for on Windows. So ensure that Node.js is properly installed by checking its version in the terminal. I can do that with node-v, and here I see I have version 20.16.0. So now let's create a new directory for our project, and we will navigate to it. So rather than clicking on this icon, I can just do that through the command line. So I'll do mkdir for making a new directory, and I'll name it ES6, I'll name it underscore ES6 Tooling. Now I specified the underscore so that this directory shows up first when I view my project files in VS Code. So now let's change directory into that new folder that we created. So now we will create a package.json file. So first let's cover what JSON is. JSON stands for JavaScript Object Notation, and it is a lightweight data interchange format that is easy for us to read and write, and easy for machines to parse and generate. It is often used to transmit data between a server and web applications, serving as an alternative to XML. XML standing for Extensible Markup Language. So JSON is a more modern way to do this. JSON data is structured as key-value pairs within curly braces and supports nested objects and arrays. So let's run the following command to create a package.json file in this new directory that we created. And this file will help us manage all of our project's dependencies and other configuration. So I'll run npm, and then the keyword init, and then --yes to accept all the default settings. So after I run this creates a new file named package.json to help manage my npm dependencies. So I can close this. So here I see it is just a JavaScript object containing properties. So now let's focus on setting up Babel. So this is to transpile modern JavaScript in ES6 Plus to backward compatible JavaScript like ES5, and we will use Babel to accomplish this. So let's clear this out. So step one is we want to install the necessary Babel packages. You can also reference the documentation at babel.dev/docs/usage. So now let's install the necessary Babel packages using npm. These include Babel CLI, Babel core, and a preset package, Babel preset environment, which includes all the latest ECMAScript features. So we can do that with npm install, then at Babel/CLI, then at Babel/core, at Babel/preset environment, and we will specify a flag for save dev. So it's 2 hyphens, save, hyphen, and then dev. And so what this does is that this installs the packages as developer dependencies. So let's discuss what these packages stand for. So Babel CLI, this provides the Babel command line interface for running Babel from the command line. So Babel core, this contains the core functionality of the Babel transpiler. In Babel preset environment, this includes plugins to enable transformations for all modern JavaScript features. So let's run this. So our packages have been installed successfully. So I'll do Command K to clear this, and then Command J to close it. And here we see our 3 developer dependencies have been installed, and they are now listed in our package.json file. So now we need to configure Babel. So we want to update our scripts here. So our scripts determine different command line scripts that we can run. So I'll add comma, and I will name this script Babel. So the value will be what command we want to run, which will be Babel, then index.js, which will be our project file, and then we'll specify the output with -o, and it will be in the build directory /index.js. So let's create a build directory in here. So it'll be build, and let's create another file, index.js. So here we replace our ES6 JavaScript, and after transpiling it, the result will be stored in the build directory. So we also need to add a file, and it will be Babel rc. So by prefixing it with a period, this means that this is a hidden file. So Babel rc is a configuration file used by Babel, which is a JavaScript compiler, to specify options and presets for transforming your JavaScript code. The name Babel rc stands for Babel Resource Configuration. So we'll just define this object here. So the key will be presets, and the value will be an array with the string at Babel /preset environment. We can save that. So let's go back to our index.js file, and let's write code in ES6 which uses modern features. So I'll specify a class, and I'll name it programmer. Now I'll define a public field, so I'll say the role of the programmer, and we'll just assign this to developer. Now we'll define a private field, so this is a modern syntax, and I'll name it experience. So now let's define our constructor function. This takes in the name, this takes in the technology they work with, and I'll say experience. So we will set the name. We can set the technology they work with, and let's set the private field of experience. So assign this to experience. Let's define, I'll close the sidebar so we can see the code better. So Command B, I'll name it develop, and then this will log out, backtick, this.name, develops software using this.technology with this.experience. This is actually a private, so I need the hash for it. Years of experience. So we can save that. And I'll have another method, which is getExperience, for accessing this private field. And this will return this.experience. And also we will export it. So we use that export keyword. So here we see this class is using the modern features of having a private field, but this language feature is not supported in JavaScript ES5. So that's why we need Babel to transpile this index.js file to ES5 syntax. So let's navigate again to our package.json, and we have this script that we define. And so we can execute this from the command line, and it will run this command specified here as the value. So let's bring up with Command J or Control J, and I'll run npm run, and then the name of the script, which is Babel. So here in our output, if we view the build directory, the result of transpiling this modern ES6 code can be found here, and this is the result of using Babel. So this code is now usable for browsers that only support older versions of JavaScript. So now let's cover integrating Webpack for more efficient builds. While Babel is excellent for single files, Webpack is more suitable when your project consists of multiple files, as it bundles all your project's JavaScript into one or a few files. Webpack will minify both your code and the final bundles to reduce file sizes. Minifying JavaScript code involves removing unnecessary characters like spaces, comments, and line breaks to reduce file size and improve load times without changing its functionality. So step 1 for setting up Webpack, you will install Webpack and configure it to work with Babel to handle the entire project, not just individual files. And second, we can automate with npm scripts. So we navigate back to package.json. We will update package.json to include a script that runs Webpack, ensuring all your JavaScript files are processed through Babel and bundled correctly. We will cover this in the next lesson. So in conclusion, by following these steps, you set up a modern JavaScript development environment capable of handling ES6 syntax and producing code compatible with older browsers. This setup ensures that your development process is efficient and your applications are robust and maintainable. What command do you use to initialize a new npm project, and what file does it create? To initialize a new npm project, you use the command npm init --yes. This command creates a file named package.json, which manages your project's dependencies and configuration. Why is Babel used in a JavaScript development environment, and what does it transform? Babel is used in a JavaScript development environment to convert modern JavaScript code, so this refers to ES6 and newer, into an older version, so this is ES5, that can run in any browser. This ensures that new features and syntax can be used without worrying about browser compatibility. What is the purpose of the .babelrc file, and how is it typically structured? The purpose of the .babelrc file is to configure Babel, specifying how JavaScript code should be transformed. It is structured in JSON format and usually contains an object with properties like presets and plugins that define which transformations to apply. Webpack is a powerful tool that bundles JavaScript files into a single file, optimizing load times and simplifying deployments. Webpack is a very large topic, and it's a very configurable technology. So this course lesson will just scratch the surface of its capabilities so that you are familiar with it, and you can explore the documentation at webpack.js.org. So from a very high level, Webpack takes many files and optimizes it for production by bundling everything into either a single file or a smaller amount of files. So Babel, on the other hand, transpiles modern JavaScript, so ES 2015 or newer, into backwards compatible versions so that our code can successfully run on older browsers, and while in development, we can still utilize the newest language features and syntax of modern JavaScript. So let's continue with the project that we were working on in our previous lesson. Let's bring up the integrated terminal with Command J or Control J, and we'll run npm install, and we'll install the package of Webpack, Webpack CLI, Babel loader. We'll specify the flag of save dev and -- legacy peer dependency. So this package, Webpack, is a powerful module bundler for JavaScript applications. It takes modules with dependencies and generates static assets representing those modules. So Webpack CLI, this is a command-line interface for Webpack. It provides commands to initialize, run, and configure Webpack from the terminal. So this package, Babel loader, this is a Webpack loader that allows Babel to transpile JavaScript files. It converts modern JavaScript code, so ES6 and newer, into backwards compatible versions, so ES5, using Babel. In this flag, legacy peer dependencies, this tells npm to use an older algorithm for resolving peer dependencies, which can help bypass conflict. So we'll install this. So successfully installed, we can view our package.json, and here we see these packages have been added to our developer dependencies. So now let's create a webpack.config.js file. So we can right click, webpack.config.js. So it is not mandatory to provide a custom configuration file for Webpack, as it does have a default convention. Before this course, we'll create a simple configuration file. So we want to use the CommonJS module syntax to import a library, so that's path, require, and then path. And then we would do module.exports, assign this to a JavaScript object, and here we will define our configuration. So we can specify the mode. So for now, it's just development. We'll define the entry point of our application. So we'll say that is in source and then index.js. And we will define the output. So after Webpack bundles everything, where will it place those files? So we'll specify the path. And here we will use this path that we imported. And so what this will do is this will create an absolute file path to where we want the output to be. So there's a keyword, so that's 2 underscores and directory name. And we'll specify the name of the directory to be dist for distribution. So with this configuration, we're basically telling Webpack, after you bundle all of our files and minify our code, place everything in a directory named dist. And we'll specify the file name of the output, and it'll be main.js. So now we'll use module. We will define some rules because we want to utilize Babel. So it's actually an array. Let's update that. So now it's the object and then test. So it's a regular expression of /10 \period to escape it, JS, a $, and then another /. So basically we're telling Webpack every JavaScript file, or every file that ends with the JavaScript extension. We can say exclude node modules, so the node modules directory, so we don't want to include the dependencies. And we can say use, and we want to utilize Babel to transpile our ES6 code into backwards compatible ES5 code. So we can save this. So this is our custom configuration. Don't worry about memorizing all this. This is just to demonstrate what Webpack is, so you have more insight. So here we define out the entry point of our application to be in the source directory in the index.js file, but currently our index.js file is at the root of the project. So let's create a new directory, and I'll name it source, and this will contain our source code. So I will copy this into that directory. So I'm going to create an instance of this programmer class. So I'm going to say cons dev, new programmer. So the name of Steven, the technology of JavaScript, and the experience, I'll say 10. And I will call the develop method. Now let's go to our package.json file. We want to define another script so that we can utilize Webpack. So I will name the key to be build and the value to be Webpack. So last thing I want to do is I want to create an index.html file. So index.html at the root of the project. So exclamation point and then tab. And I just want to create a simple h1 tag, and I'll say using Webpack. I also want to specify a script tag. So this will be in the distribution directory, and the output will be main.js. So now let's bring up the integrated terminal with Command and J, and I'll clear this out. So we want to run our build script. So we're going to run Webpack. So npm run build. So Webpack successfully bundled our code for our very simple project. So here we specified our output directory to be dist for distribution. And so this is the output that Webpack generated to create backwards compatible code. So once again, it's because this modern syntax that we use is not compatible with older web browsers. So we use Babel to transpile our code into ES5 syntax. And so Webpack is used to bundle our code for production. So this is a really simple example because we just have one file, but you can imagine as our projects grow and we have hundreds of JavaScript files, then Webpack becomes a mandatory tool to optimize our code for production. So here we can see what was generated. Now, I can also update this. So if I go to the Webpack configuration file, I specified the mode to be development. Let's change this to be production. And I'll bring up the integrated terminal. And let's run the build command again. So here we see the code has been minified, so everything is placed on one line. And all the spaces and new lines have been removed to make the file size as small as possible. This will help make our application faster once it's running in a web browser. So we can see this in action and actually see this in a browser. So I'll resize this. And let's open up the integrated terminal. And I'll do open and then period. So this will open up Finder on my Mac. So now I'll drag my index.html file and drag it to my browser. So let's close this out. So here in our index.html file, I have the h1 tag saying using Webpack. So we see that here. And in our script tag, this is referencing the production code that Webpack and Babel generated for us. So this code. And so the code that we were using in development was utilizing the programmer class with modern ES6 syntax. I created an instance of the programmer and called the develop method. So it logged this out. Let's check that it did that in our browser. I can bring that up with doing the developer tools. We drag that over here in our console. We get our expected log statement. View our sources, and here we see the production code that Webpack generated for us. So I can close this. So this is a very quick and brief overview of Webpack, just so you have a better understanding of what it does. So in conclusion, using Webpack and Babel together simplifies the process of modern JavaScript development by bundling and transpiling your code. This streamlined setup ensures compatibility across browsers and improves developer efficiency. So for more detailed and advanced configuration, refer to the Webpack documentation at webpack.js.org and Babel at babeljs.io. So let's recap what we covered in this section. First, we covered modules. This lesson introduced the concept of modules in JavaScript, explaining how they help organize and maintain code by breaking it into manageable, reusable pieces. We covered CommonJS. So we explored CommonJS, which is a standard for modularizing JavaScript that allows the encapsulation of functionality into reusable packages, which has been widely used in Node.js. ES6 Modules. This section covered ES6 Modules, a native JavaScript feature that supports static import and export of code, offering a more integrated and optimized way to handle modules directly in the browser or in Node.js environments. ES6 Tooling. This topic addressed various tools and technologies that support ES6 development, enhancing code compatibility across different browsers and environments. Babel. We discussed Babel, a JavaScript compiler that allows developers to write modern JavaScript code that is then transpiled into backward-compatible versions for better support across all platforms. Webpack. The lesson on Webpack provided insights into how this powerful tool bundles JavaScript files and dependencies into a single file, improving site speed and efficiency. Each topic was designed to equip you with the necessary skills to effectively use modern JavaScript tools and practices, streamlining your development process and ensuring your projects are robust and maintainable.